Section 3.3, Simplifying Algebraic Expressions. In this video, we will review the commutative, associative, and distributive properties for simplifying algebraic expressions. We will see how to speed things up with the commutative and associative properties, how to move a bit quicker with the distributive property, how to extend the distributive property, how to distribute a negative sign, and how to negate a sum. Recall the commutative and associative properties of multiplication. Commutative property of multiplication. If a and b are any integers, then the product of a and b equals the product of b and a. Or equivalently, a times b equals b times a. The associative property of multiplication. If a, b, and c are any integers, when we multiply a, b, and c together, whether we multiply a and b together in a group or b and c together in a group, the expressions are equal. The commutative property allows us to change the order of multiplication without affecting the product or answer. The associative property allows us to regroup without affecting the product or answer. Example 1. Simplify 2 times the product of 3 and x. Solution. Use the associative property to regroup, then simplify. So instead of grouping 3 and x, group 2 and 3, then 2 times 3 is 6. So the simplified expression is 6 times x. The statement 2 times the product of 3 and x equals 6x is an identity. That is, the left-hand side and right-hand side of 2 as the product of 3 and x and the product of 6 and x are the same for all values of x. Although the derivation in example 1 should be the proof of this statement, it helps the intuition to check the validity of the statement for one or two values of x. If x equals 4, then we get 2 times 3 times 4, and 3 times 4 is 12, and 2 times 12 is 24. Similarly, 6 times 4 is 24. What if x is negative 5? Then we get 3 times negative 5 is negative 15, and 2 times 15 is negative 30. Similarly, 6 times negative 5 is also negative 30. The above calculations show that 2 times the product of 3 and x equals the product of 6 and x, for both x equals 4 and x equals negative 5. Indeed, the statement 2 times the product of 3 and x equals the product of 6 and x is true, regardless of what is substituted for x. Example 2. Simplify negative 3 times t times negative 5. Solution. In essence, we are multiplying three numbers, negative 3, t, and negative 5. But the grouping symbols ask us to multiply the negative 3 and the t first. The associative commutative properties allow us to change the order and regroup. So the expression negative 3t times negative 5 is equivalent to negative 3 times a negative 5 times t. And negative 3 times negative 5 would be a positive 15. So it simplifies to 15t. Example 3. Simplify negative 3x times negative 2y. Solution. In essence, we are multiplying four numbers, negative 3, x, negative 2, and y. But the grouping symbols specify a particular order. The associative and commutative properties allow us to change the order and regroup. Group negative 3 and negative 2, and x and y. Then negative 3 times negative 2 is a positive 6, and we get 6xy as the solution. Speeding things up. The meaning of the expression 2 times 3 times 4 is clear. Parentheses and order of operations are really not needed, as the commutative and associative properties explain that it doesn't matter which of the three numbers you multiply together first. You can multiply 2 and 3 first. Then you would get 2 times 3 is 6, 6 times 4 is 24. Or you can multiply 3 and 4 first. We would have 3 times 4 is 12, then 2 times 12 is also 24. Or you can multiply 2 and 4 first. 2 times 4 is 8, 8 times 3 is 24. They are all 24, so it doesn't matter which two factors you multiply first. Of course, this would not be the case if there were a mixture of multiplication and other operations, division, addition, and subtraction. Then we would have to strictly follow the rules guiding order of operations. But if the only operator is multiplication, the order of multiplication is irrelevant. Thus, when we see 2 times 3x as in example 1, we should think it's all multiplication. It doesn't matter which two numbers I multiply together first, so I'll multiply the 2 and 3 and get 2 times 3x equals 6x. Our comments apply equally well to a product of 4 or more factors. It simply doesn't matter how you group the multiplication. So in the case of negative 3x and negative 2y, as in example 3, find the product of negative 2 and negative 3 and multiply the result by the product of x and y. That is, negative 3x times negative 2y equals positive 6xy. Example 4. Simplify 2a times 3b times 4c. Solution. The only operator is multiplication, so we can order and group as we please. So we'll take the product of 2, 3, and 4 and multiply the result by the product of a, b, and c. That is 2a times 3b times 4c equals 2 times 3 times 4, which is 24, times a, b, c. The distributive property. Multiplication is distributive with respect to addition. The distributive property is where a, b, and c are any integers, then a times the sum of b and c equals the product of a and b plus the product of a and c. For example, if we follow the rules guiding order of operations and first evaluate the expression inside the parentheses, then 3 times the sum of 4 and 5 equals 3 times 9, since 4 plus 5 equals 9, then 3 times 9 is 27. But if we distribute the 3, we get the same answer. 3 times the sum of 4 and 5 equals the product of 3 and 4 plus the product of 3 and 5. 3 times 4 is 12, 3 times 5 is 15, and 12 plus 15 is 27. Example 5. Use the distributive property to simplify 3 times the sum of 4x and 5. Solution. Distribute the 3. We get the product of 3 and 4x plus the product of 3 and 5. Multiply 3 times 4x is 12x, and 3 times 5 is 15. Multiplication is also distributive with respect to subtraction, where a, b, and c are any integers, then a times the difference of b and c equals the product of a and b minus the product of a and c. The application of this form of the distributive property is identical to the first, the only difference being the subtraction symbol. Example 6. Use the distributive property to simplify 5 times the difference of 3x and 2. Solution. Distribute the 5. 5 times the difference of 3x minus 2 equals the product of 5 and 3x minus the product of 5 and 2. The product of 5 and 3x equals 15x, and the product of 5 and 2 is 10. So we get 15x minus 10. Example 7. Remove parentheses. A, negative 9 times the sum of 2t plus 7. Use the distributive property. We get the product of negative 9 and 2t plus the product of negative 9 and 7. Then, negative 9 times 2t is negative 18t, and negative 9 times 7 is negative 63. To write the answer in the simpler form, the plus and the negative is the same as minus 63. So, the answer is negative 18t minus 63. B. Use the distributive property. The expression is negative 5 times 4 minus 3y. If we distribute the negative 5, we get the product of negative 5 and 4 minus the product of negative 5 and 3y. The product of negative 5 and 4 is negative 20, and the product of negative 5 and 3y is negative 15y. Writing the answer in a simpler form, the minus and the negative would be the same as adding 15y, so the answer is negative 20 plus 15y. Writing mathematics. Example 7 stresses the importance of using as few symbols as possible to write your final answer. Hence, negative 18t minus 63 is favored over negative 18t plus a negative 63, and negative 20 plus 15y is favored over negative 20 minus a negative 15y. You should always make these final simplifications. Moving a bit quicker. Once you've applied the distributive property to a number of problems, showing all the work as in example 7, you should try to eliminate some of the steps. For example, consider again example 7a. It's not difficult to apply the distributive property without writing down a single step. So if we distribute negative 9 in the expression negative 9 times the sum of 2t plus 7, we get negative 18t minus 63. Here's the thinking behind this technique. First, multiply negative 9 times 2t, getting negative 18t. And second, multiply negative 9 times plus 7, getting negative 63. Note that this provides exactly the same solution found in example 7a. Let's try the same technique in example 7b. Negative 5 times the difference of 4 minus 3y equals negative 20 plus 15y. Here's the thinking behind this technique. First, multiply negative 5 times 4, getting negative 20. Second, multiply negative 5 times negative 3, getting a positive 15y. Note that this provides exactly the same solution found in example 7b. Extending the distributive property. Suppose that we add an extra term inside the parentheses. If a, b, and c, and d are any integers, then a times the sum of b, c, and d equals the product of a and b plus the product of a and c plus the product of a and d. Note that we distributed the a times each term inside the parentheses. Indeed, if we added still another term inside the parentheses, we would distribute a times that term as well. Example 8, remove parentheses. Negative 5 times 2x minus 3y plus 8. Solution. We will use the quicker technique distributing negative 5 times each term in the parentheses. So, first multiply negative 5 times 2x, getting negative 10x. Second, multiply negative 5 times negative 3y, getting a positive 15y. Third, multiply negative 5 times plus 8, getting a negative 40. Example 9. Remove the parentheses. Negative 4 times the expression negative 3a plus 4b minus 5c plus 12. Solution. We will use the quicker technique, distributing negative 4 times each term in the parentheses mentally. Here's our thought process. First, multiply negative 4 times negative 3a, getting 12a. Second, multiply negative 4 times positive 4b, getting negative 16b. Third, multiply negative 4 times negative 5c, getting positive 20c. Fourth, multiply negative 4 times positive 12, getting negative 48. Distributing a negative. It is helpful to recall that negating is equivalent to multiplying by negative 1. Let a be any integer, then negative 1 times a equals a negative a, and negative a equals a negative 1 times a. We can use this fact combined with the distributive property to negate a sum. Example 10. Remove parentheses, a negative times a plus b. Solution. Change the negative symbol into multiplying by negative 1, then distribute the negative 1. So, a negative times the sum of a plus b equals a negative 1 times the sum of a and b. Then distribute the negative 1 to get negative a minus b. We chose to use the quicker technique of distributing the negative 1. Here's our thinking. Multiply negative 1 times a, getting negative a. Then multiply negative 1 times positive b, getting negative b. Example 11. Remove parentheses. Negative times the difference of a and b. Solution. Change the negative symbol into multiplying by negative 1, then distribute the negative 1. So negating is equivalent to multiplying by negative 1. Negative times the difference of a and b equals a negative 1 times the difference of a and b. Distribute the negative 1 to get negative a plus b. We chose to use the quicker technique of distributing the negative 1. Here's our thinking. First, multiply negative 1 times a, getting negative a. Then, multiply negative 1 times negative b, getting a positive b. The results in example 10 and example 11 show us how to negate a sum. Simply negate each term of the sum. Positive terms change to negative. Negative terms turn to positive. Negating a sum. To negate a sum, simply negate each term of the sum. For example, if a and b are integers, then a negative times the sum of a and b equals a negative a minus b, and a negative times the difference of a and b equals a negative a plus b. Example 12. Remove parentheses. Negative times the expression 5 minus 7u plus 3t. Solution. Simply negate each term in the parentheses. So, 5 plus negative 7u plus 3t becomes negative 5 plus 7u minus 3t.